Numbers, page 4. So let's do an example problem here. We have a inequality, 8 plus x is greater than 5. And then we're going to simplify this inequality so that it only has the variable on the left side. So how do we do that? Well, the 8's something we need to get rid of. So what if we subtract 8 from both sides, since the 8 is added here? So if we subtract 8 from both sides, we're going to get x greater than 5 minus 8, which can be simplified to x is greater than negative 3. Okay, so now we have it in this form. We could actually represent it on the number line. Do you see how negative 3 here? We're going to put an open circle over it, and then we're going to draw an arrow going to the right. The reason why is because since we have greater than negative 3, we're going to extend the arrow to the right, which is the greater than side. And then since it's greater than and not greater than or equal to, then we're going to put the open circle over the negative 3 because negative 3 is not included in the interval represented. Okay? Alright, the second part says state whether p equals negative pi is a solution to the inequality. And the way we can do that is we could look at the number line and then we could plot negative pi. Negative pi is negative 3.14159, etc. It's about there, so you can see that it's not in the green region, so it is not a solution. Okay, so let's do 1a. Solve these inequalities. Okay, so we got 0.5 is less than x divided by 2 is less than or equal to 1.5. We need to get rid of this divided by 2 in order to get x by itself. We could multiply the left side, the right side, and the middle times 2, and then we'll be maintaining the inequality, right? So it would be 0.5 times 2 less than x less than or equal to 3, because 1.5 times 2 is 3, right? So, and then this could be simplified to 1. Now represent the solution to that on the number line. So we're going to write here, well, it's going to be an x is between 1 and 3, right? So we'll have 1. And we'll have 3, and the 3 is included in the interval, but the 1 is not included because it's less than and not less than or equal to. So I'll make an open circle on the 1 and a closed circle on the 3, and then I'm going to darken the region in between the 2 because it does say x is between 1 and 3. Okay? Now let's do number 2. So 3 minus x is greater than or equal to 1. Now in this case we want to get x by itself again, so we're going to subtract 3 from both sides. We're going to get negative x is greater than or equal to 1 minus 3. Then we're going to have negative x is greater than or equal to negative 2. And now here we're going to have to do something a little bit tricky. Did you know that if you multiply both sides of an inequality by a negative number that you reverse the sign? Well, let me show you why that's true. If you have negative 3 is less than negative 2. We know that's true. What if I multiply both sides by negative 1? If I multiply both sides by negative 1, then I will get a positive 3 less than positive 2, and then all of a sudden it's not true anymore. So you can see that if you multiply both sides by negative, you also have to reverse the inequality. You have to point it in the other direction because the exact opposite is true. If you look at a number line, you can kind of see why that's true. I'm gonna write out the negative 3 is less than negative 2. So negative 3 is here. Negative 3 is less than negative 2, right? And then, but look at what happens. I wrote that kind of messy. So negative 3, negative 2. You can see that negative 3 is indeed less than negative 2. What happens when you multiply by negative 1? When you multiply by negative 1, you are reflecting them about the 0, and then you end up with positive 2 and positive 3, and now you can see that, because of the reflection, you are going to have everything exactly in the opposite order. So all your less thans are going to become greater thans, right? This was less than. Now 3 is going to be greater than 2. Okay, so that is why when you multiply by a negative number, you always have to reverse all the inequalities. So when we multiply both sides of this by negative 1 so that we can get x by itself, then we're going to have positive x is less than or equal to negative 3. We have to reverse the inequality. So now we're going to have a negative 3 here, and we're going to have a dot, a filled in dot, because it's less than or equal to, and then we're going to go to the left. Okay, now let's do part C. State whether the numbers q equals 1.5 and t equals square root of 5 are solutions to the inequalities. Okay, 1.5. Is 1.5 a solution to this? Yeah, it's about there. So yes, 1.5. What about the square root of 5? Well, first of all, let's figure out in decimals what square root of 5 is. Square root of 5, I think it's like 2 something. 2.24 about. Okay, so 2.24. Is 2.24 in here? It is. So yes, square root of 5 also. Okay, what about for the second interval, which is x is less than or equal to negative 3? No, the x point 1.5 is not part of the solution, and square root of 5 is also not part. They're both positive numbers, and you can see that the solution to 3 minus x is greater than or equal to 1 is the negative numbers below negative 3, so they're not part of the solution. Okay. Number 2, solve these inequalities. So now what we're going to do is, again, we're going to isolate the x, right? So if we have 2x plus 1 is greater than negative 1, we're going to subtract 1 from both sides, and then we're going to get 2x is greater than negative 2. We haven't multiplied by any negatives, so no, we're not going to reverse the inequality. Now we're going to isolate 2x completely by dividing both sides by 2. Now we're going to have x is greater than negative 1. Okay. So we have solved the first one. What about the second one? The second one is 4 is less than or equal to x plus 1 is less than or equal to 8. And now to get x by itself, we need to get rid of the plus 1. We could subtract 1 from each one of these expressions, and then we're going to have 3 is less than or equal to x is less than or equal to 8 minus 1, which is 7. So we're done. That was easy. Last one, 2 minus x is greater than negative 1. So here, first thing we're going to do is we're going to subtract 2 from both sides, and we'll get negative x is greater than negative 1 minus 2, which is equal to negative 3, of course. Now, to get x all by itself, we're going to multiply both sides by negative 1. And when we do that, we do need to reverse the inequality. So we're going to have x is less than negative 3 times negative 1, which is 3. Okay. X is less than 3. So now we're going to represent each of these solutions on the number line. So first we're going to have x is greater than negative 1. So we're going to have negative 1, and we're going to have an open circle because the interval represented is greater than, it's not greater than or equal to. And then we're going to have 3 and 7. So we're going to have 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. And then we're going to color in the region, the interval in between the two, and we're going to put solid dots over the 3 and the 7 because these are included in the interval. Okay, and then finally we're going to have an interval x is less than 3, which is to the left of 3, and the question is, are we going to put a open circle or a solid dot over the 3, and since it's less than or not, and not less than or equal to, it would be an open circle. Okay. Now it just asks if each one of these numbers is within the solution interval for these expressions. And just, can you see that this is this expression, this is this expression, and this is this expression? So we've already simplified the x's. So all we need to do is compare each of these numbers to these drawn intervals. It's probably the easiest way, and then we can say whether or not negative 2/3, for example, is in each one. So negative 2/3, let's see, is it in this interval? Negative 2/3 is going to be slightly to the right of negative 1, right? Because negative 2/3 is negative 0.666. So yeah, this is inside that interval. And what about negative 2/3? Is it inside this interval? Well, no, because negative 2/3 is kind of over here on the negative side of 0. These are all positive numbers, so no, they're not. What about this one? Negative 2/3, is it in this interval? Yeah, it is, because this interval here includes all negative numbers, right? Everything to the left of 0 is definitely included, so this is also okay. What about square root of 10? Is square root of 10 in this interval? Remember, square root of 10 is about 3.5 3.16 something. We can use our calculator to make sure. 3.16, a number that's coincidentally kind of close to pi. So square root of 10 is 3.16. So is 3.16 in this interval? Yeah, all positive numbers are in this interval, right? Everything to the right of -1 includes all positive numbers. So this is, yes, in the interval. What about between 3 and 7? Is square root of 10 in between 3 or 7? Yeah, it is. 3.16 is slightly to the right of 3. So it is. What about to the left of 3? Less than 3. Is 3.16 less than 3? No, it's not. So that one we're going to leave blank. And then what about 2 pi? 2 pi, remember, is about 3.14 times 2, which is about 6.28, and we can get a more accurate number by doing pi times 2. It'll give us 6.28 blah, blah, blah. So is 6.28 in this interval? Yeah, all positive numbers are in this interval. So yes, it is. What about this interval? Is 6.28 between 3 and 7? Yeah, 6.28 something is between 3 and 7. Finally, is 6.28 between, or like in this interval, everything to the left of 3? No, it's not. 6.28 something is to the right of 3, so it's not in that interval. So here is your complete answer for this section.